In this video I will show you the best practice to capture historical buildings like this one here with a small aircraft like the Mini 5 Pro. We can see here the final result from the Gaussian Splat from this church in Brienz, and we will see in the video how we can get a result like this. What you can see here is the reality scan photogrammetry build from this church, and you can see here it's a polygon mission with a vertical polygon mission. You can see here the camera position for this shooting in reality scan. You can see it's a polygon point of interest mission, so the image is always centered to the church, but I follow a polygon grid around this church. If you have a look in Google Earth, you can see here the church and the polygon mission. So it's surrounding this church. And on Google Earth I can check that I have no conflict with the other buildings. So I can check the mission. Now let's see in the map creator, in the latest version, I have here the version 1.0.4, how we can build a mission like that. So it's very important that you set the start point of the mission with the right altitude. Later I calculate automatic the elevation of this mission so that you get the real result in Google Earth. It's all done automatically, but it's very important that you choose the first waypoint where you will start the aircraft. I'm actually on an altitude from 15 meters for this mission. So let's start to draw this polygon. So I will start here. And I will go around this church. Now to build the new mission type of the point of interest, you have to select here POE polygon mission. And now we have the start altitude, we have the end altitude, I will put it on 15 meters. And we have the step. The step is depending on the distance you already set. And now it creates the mission. Let's see in the 3D plot how this works. So you can see here in the 3D plot how this mission works. So the mission starts here, it goes counterclockwise, then it goes up and it goes clockwise back on this position here, and it goes up, backwards and forwards to complete the mission. If you are not comfortable with the flight path, you can change the mission flight path, 15 meters, and it will recreate the mission. Then the next step is to export the CAML file, save the CAML mission, and then you can check it in Google Earth. If everything is okay, you can save the CAMZ mission and import it with the DJIKMZInjector into the RC control. At the end, we have all the images from this mission. I put it in an image folder, so here you can see the project. I have images, and then, as in the previous video, we take this image folder and we put it on the Run Coolmap brush batch process. I will not do that, I've already done. So you get the dense folder, and you have then the result for the Gaussian Splat here after 5,000 iterations and after 10,000 iterations. In my previous video I explain in details how we can do that. So we have this final result. From here I've cleaned up the image. You can export it into a viewer app, and so you have the final result like here, and you can embed this on your web page. For the web page in HTML you can change the background. You can also use a white background, and this will give you another result. You can see it here, it's with the white background, and this gives the possibility that you implement it onto your background in the web page. So you can see it here on the map creator web page. I embedded this image onto this website where I explain with small steps how I did this image. Additional mission I did for this church, so you can always save or load the mission file. And we have another possibility to get results like this. I will load another church. Another mission type is the helix, not the double helix, as we have a tower here. And you can see the result from this mission into the web browser. This mission was made with a helix and not with a polygon POE mission. I always get the best results with these two mission types. So we have the helix mission and we have here the point of interest polygon mission. With these two mission types for historical buildings, I get the best results. New version, I've implemented another map type. What you can see here, the terra is very steep, so it's important that we have this height line here. So you can see if you place a mission that you go not too close to the terra. We cannot see that on OpenStreetMap, but here we can see the lines. So that helps us to get not too close to the terra. Versions, the search location was only for Europe. Now you can go on the whole world. And it's also a question of speed. Now we have much more speed to search locations. I did some changes at the DJI-KMZInjector. So we have now auto detect at the beginning, and it's not depending on device names. It works for MTB, ADB, and on macOS also for iOS. What you can see here, I tested DJI, the new mission hub. Until now they have only a preview like that, but I guess that they will implement also a preview like I do it in the map creator. What we can see here is the mission from this church, the polygon point of interest mission. And I also created a helix mission for this church, but I only used the polygon mission. The new DJI-KMZInjector connects automatically, and we have now on macOS also iOS connection. And with the iOS connection we can see the mission name, the number of waypoints, and we can create missions without replacing a dummy mission. So let's see how this works. If you connect an iOS device, an iPhone or an iPad with DJI Fly on it, do not open DJI Fly when we create directly a mission on the iOS device. So let's go to the map creator. Let's create a small mission. I will decrease the photo distance so we have an overlap from 75%. Now you can see on macOS this icon. I can select it, and now I can directly upload this mission to the iOS device. I repeat, do not open DJI Fly when we do that. So you saw that, it's just a few seconds and we have uploaded the mission. Let's see what's on the iOS device. So we refresh the mission and we can see here our new mission. We have 24 waypoints. So I repeat, do not open DJI Fly while you do that. It's important. We cannot create missions on DJI Fly when it's open. It's only possible when it is closed. So that's now very comfortable. You saw it with just a few clicks, 2-3 seconds, and I have uploaded a new mission. We don't need to replace missions anymore. This works actually only on macOS and for iOS devices. If you connect a DJI RC2 or RC2 Pro, it will automatically connect to MTB and show the missions. On the DJI RC2, we still have to replace the mission. We cannot directly create the mission. We have no access on the database. So it's very easy now to create new missions. If we have here the DJI-KMZInjector, if you are on macOS and you have connected an iOS device, you have this new icon here, Create Mission. So with Create Mission, you have the possibility to select a KMZ file and it will directly upload this KMZ file to DJI Fly without replacing a dummy mission. Also here, it's important, if you connect the iOS device, don't open DJI Fly while you are doing this. We can see in the log that before we had 37 missions and now we have 38 missions. The upload of the preview here, you can see we can select between satellite and also topography. Topography is very interesting to see the height lines if you are on a steep terrain, and you will get the same view here with the map you just selected on the map creator. So this is very comfortable to see the mission, also if we have satellite view. And here, for example, what you can see for this polygon point of interest mission, I indicated in the mission name 18 meters. If we upload the mission, you can get also a name for the mission. What I will say here, it's important that you have different height. If you are on terrain, maybe 22 meters or 30 meters is better, or even 15 meters. But that you can only see on terrain. For example, here we have 3 trees, and I don't know the height of these trees. So it's always important to have a choice on the terrain if you are doing missions very low, that you have different missions uploaded. You can also see here, for example, the helix. I indicate the start point height with 25 meters. For example, a barn like this one here, I can go down to 10 meters, but I can have, for example, a mission for 10 meters, for 15 meters and for 20 meters. It's very easy here to change, only change the altitude and you get a new mission. I will change this to polygon. So this is typical the polygon mission, which gives very good results for Gaussian splatting or photogrammetry. So it's important that this start altitude, you have different missions on your device and you choose on place which mission is best. Also important point here, we get different pitch angles. I have here, for example, pitch angle 71 degrees. I will just change the mission type. We can see it better if we do a mission with a helix. So here, for example, I have 71 degrees down to the point of interest. If I change the altitude, it changes automatically also the pitch angle. So that's very important. If I save, for example, now this mission, I will give it the name 26 meters. So I know on place the altitude. So I can create different missions. And for all point of interest missions, that is possible to have always the right pitch angle. Another point here, for point of interest missions, it's possible to export a sky splat mission. The sky splat mission has the big difference. It's a video, it's not getting images during the missions, it's a video. Maybe you saw the YouTube videos about sky splat. It imports videos automatically into Blender and creates then photogrammetry results. So you can export images. So that's also possible for the helix mission and also for the point of interest polygon mission. So you can use SkySplat. SkySplat export, for example, for a 4K videos, the resolution for the 4K video. So it's not the same image quality if you use a mission with images. So I recommend not to use this option here. Only if you like that to work with Blender with SkySplat, you can use it. But in the normal usage, it's better to work with individual images. Map Creator and the DJIKMZInjector is developed on Python. That has the advantage that I can address directly different platforms like Windows, macOS and Linux with the same code. So that's more easy to develop software. If you like to keep it public, you can make a donation for this software, so I'll add new features in the future and keep it public. With the missions like double helix, helix and point of interest polygon mission, we have very professional tools to get amazing results with photogrammetry and also Gaussian splatting with only a few images. In the next video, I will show you what we can do with Reality Scan, the new version with the cool map export. I created a Python tool who do the whole workflow in a terminal full automatic. You don't need to open Reality Scan. It's all done full automatic like in the last video. You get the folder on a batch program and then it does the work full automatic. So I hope this video was useful. Thanks for watching. Until the next time.